Good morning, my dear students. So here we are with another part of chapter Integers, part 2. Let's begin. Multiplication of integers. We know that multiplication of a whole number is repeated addition. Multiplication of a positive and a negative integer. For example, 5 plus 5 plus 5 plus 5 is equal to 3 into 5, that is equal to 15. Can you represent addition of integers in the same way? Yes, we have done this in previous class. When we do 3 into minus 5, we get the answer as minus 15. Till now, we multiplied integers as positive integer into negative integer. Let us now multiply them as negative integer into positive integer. We first find minus 5. Now we have 3 into 5. Please see the pattern. 2 into 5 is equal to 10, that is equal to 15 minus 5. 1 into 5 is 5, which is 10 minus 5. 0 into 5 is 0, which is 5 minus 5. Minus 1 into 5 is 0 minus 5, that is minus 5. Minus 2 into 5 is minus 5 into 5, that is minus 10. Minus 3 into 5 is minus 10 minus 5, which is equal to minus 15. We already have 3 into minus 5 as minus 15. So we get minus 3 into 5 is equal to minus 15, that is equal to 3 into minus 5. Thus we find that while multiplying a positive integer and a negative integer, we multiply them as whole numbers and put a minus sign before the product. In general, for any two positive integers a and b, we can say a into minus b is equal to minus a into b, that is equal to minus of a into b. Multiplication of two negative integers. Let us find the product of minus 3 into minus 2. The pattern is as we discussed earlier. Do you see any kind of pattern and observe the changes? We multiply the two negative integers as whole numbers and put the positive sign before the product. Thus we have minus 10 into minus 12 is plus 120, which is written as 120. Similarly, minus 15 into minus 6 is plus 90, that is equal to 90. So in general, for any two positive integers a and b, minus of a into minus of b is always equal to a into b. Rules for multiplication and division of integers. So here is a flow chart which tell you the basic rule. First case, when signs are same. So the sign of answer is always positive. When signs are different, sign of the answer is always negative. Only these 2 points you have to remember. Now we will discuss properties of multiplication of integers. Closure under multiplication. Closure property we have already studied number of times. Closure property states that when two integers a and b are multiplied, we get their product as an integer. Please see table 1. Minus 20 into minus 5 is 100. So 100 is also an integer. Minus 15 into 17 is minus 255. That is also an integer. Commutativity of multiplication. We know that multiplication is commutative for whole numbers. Let us see what happens in the case of integers. Observe the following table. 3 into minus 4 is minus 12 and minus 4 into 3 is also minus 12. So we can conclude that 3 into minus 4 is equal to minus 4 into 3. The above examples suggest multiplication is commutative. So in general, for any two integers a and b, a into b is equal to b into a. Multiplication by 0 states that the product of a negative integer and 0 is always 0. Multiplicative identity states that when an integer is multiplied by 1, answer is always the integer only. In general, for any integer a, we have a into 1 is equal to 1 into a, that is always equal to a. Associativity for multiplication. Consider minus 3, minus 2 and 5. Look at minus 3 into minus 2 in the bracket into 5 and minus 3 into minus 2 into 5 in bracket. In the first case, minus 3 and minus 2 are grouped together, and in the second case, minus 2 and 5 are grouped together. We see that minus 3 into minus 2 in the bracket into 5 is 6 into 5, that is 30, and minus 3 into minus 2 into 5 in the bracket is minus 3 into minus 10, that is again 30. So we get the same answer in both the cases. Therefore, in general, for any three integers a, b and c, a into b in bracket into c is equal to a into b into c in bracket. It only explains that on changing the group, the value doesn't change. Distributive property. We know 16 into 10 plus 2 in bracket can be written as 16 into 10 in the bracket plus 16 into 2 in the bracket. Let us check if this is true for integers also. Try to observe the pattern yourself. Can you see any common thing? Yes, you are correct. Distributivity of multiplication over addition is true for integers also. So in general, for any integer a, b and c, a into b plus c in bracket is equal to a into b plus a into c. Making multiplication easier. Consider the following example. We can find minus 25 into 37 into 4 as minus 25 into 37 in the bracket into 4. That is equal to minus 925 into 4. That is equal to minus 3700. Or we can do it in another way. That is minus 25 into 37 into 4 can be written as minus 25 into 4 in the bracket into 37. So minus 25 into 4 will give minus 100. Minus 100 into 37 is minus 3700. Which is the easier way? Obviously, the second way is easier because multiplication of minus 25 into 4 gives a minus 100, which is easy to multiply. Note that the second way involves commutativity and associativity integers. Another part, we find that commutativity, associativity and distributivity of integers help to make our calculations simpler. Let us consider one more example. Minus 23 into 48 is equal to minus 23 into, in the bracket, 50 minus 2. 48 can be written as 50 minus 2. Now let us distribute them. Minus 23 into 50 minus of minus 23 into 2. Minus 23 into 50 is minus 1150. Minus 23 into 2 is minus 46. So on solving them, the answer is minus 1104. 52 into minus 2 plus minus 52 into 2. Minus 52 into 2 can also be written as 52 into minus 2. Therefore, 52 into minus 8 plus minus 52 into 2 can be written as 52 into minus 8 plus 52 into minus 2. Taking 52 common and putting minus 8 and minus 2 in the bracket and adding them, we get 52 into minus 10, that is minus 520. So this is the end of today's lecture. Now your homework is exercise 1.2 of page 12 from chapter 1, and I am attaching the exercise here for all those who have not got the book yet.